This is a demonstration of Cavalieri's principle, software I wrote at the Visual Geometry project in 1987, before I began working on the Geometer Sketchpad. And the idea of Cavalieri's principle is a simple one. You attack a figure with a tool, and you have a choice of figures and you have a choice of tools. But unfortunately, this app is so old that I can't run it even on my 10.3 Macintosh I have here. So I'm running a 20-year-old piece of software on a 10-year-old Mac. And if I go to the Figures menu, Cavalieri's principle used to draw your choice of figures directly in the menu, and that will crash the 10.3 Classic emulator. So I'll stay away from that. We will only use this figure, which is a rather odd one, sort of the ultimate figure in the program, Cavalieri's head. But originally you had a choice of figures, a circle, a square, a triangle, draw your own, or Cavalieri's head. So once you've established a figure, the next step is to take a drawing tool. And you can see dangling from my mouse, I have a straight edge drawing tool. And if I click the button and move left or right, the straight edge locks in on a left or right trajectory. And then when it hits the figure, it begins deforming it by pushing it like the figure was made of sand, or more precisely like the figure was made of an infinite number of infinitely thin horizontal plates that you could slide back and forth simply by sort of plowing into it with these various tools that you have. And the idea is that as those plates shift left and right, you're changing the perimeter of the shape, but you aren't changing the area because they're the same number of plates or horizontal cross sections that are not actually changing area as you shift them about.
Let's take an interlude in Sketchpad because Cavalieri will crash if we attempt to show a triangle. But Cavalieri's principle helps us think about why it is that shearing a triangle preserves its area, or shearing the parallelogram formed by completing this triangle here preserves its area. You can see below, as I shear the triangle, the perimeter is changing, but the area stays constant. And what Cavalieri's principle says is you can treat any shape as if it were a stack of these horizontal plates that you're sliding back and forth. Each horizontal plate has the same area, so sliding them doesn't change the net area of the total figure. If you think of your area formula for a triangle, then this becomes obvious. The base is not changing under this shear. The height is not changing, so half base times height isn't changing, which means area is constant.
If you look in the Tools menu, you can see the variety of tools you have. In addition to the straight edge where you choose an angle or length, you can choose a bludgeon for making specific edits to the contour. But really the interesting shape is to use the original profile, the profile of your original figure, as a tool. Because if you were to sort of come and hit an arbitrary figure with that, you get an arbitrary shape. But if you exactly line up all of your plates, you should, I almost got them, wind up with the original figure again. So many different tool options. As I said, though, I can't show it, many different figure options. And in general, Cavalieri has an incredible number of options. It's a totally overproduced piece of software. So these buttons up top bring all of the plates flush left or flush right or flush center. These tags let you shear or symmetrize the plates. If I hold down Option and press these things, I think, yes, they turn into scroll buttons. Down here, I can temporarily preview my original figure compared to my current figure, or even my original figure on top of, or even better, look, beneath the original, the current figure. If it mattered, I could change to centimeters. So many options, very typical. I think the best part of all of Cavalieri is the About box. I'm certain that more than half the time I spent working on the software, I spent on the About box. Look at this. This is just a majestic piece of work for 1987. There you go. The sun on the horizon forever. So I think really the important piece that Cavalieri contributes to Sketchpad, though it was an experiment for me in coming to learn a little bit about the development environment of the Macintosh and what sort of tools I was going to be using at the Visual Geometry project to work on Sketchpad, that here you see already wrestling with the idea of the mouse as a way of mediating directly mathematical representations with a continuous and sort of engaged, visceral, tangible form of action. And the idea of dragging vertices and really wrenching your triangles around grows out of this earlier idea, I think perhaps of attacking and assaulting shape, deforming shape while preserving certain mathematical properties. So I wouldn't say Sketchpad grows out of Cavalieri in any grand scheme. Cavalieri is a simple program, whereas Sketchpad's an ambitious one. But I think some of the very earliest seeds of dynamic geometry exist in this tool. So that's it. Goodbye, Cavalieri.